this lesson, we're going to learn how to get solution sets to equations that have two variables. In the past, you've been familiar with equations that have one variable. For example, 3x equals 15, and we're able to get a solution set from that. Because x equals 5, we plug it in, check our work. We can express the solution set with a set notation. We can also express it graphically. And so today's lesson will focus on equations that have not one but two variables. So let's say that we have this equation. It has two variables. We can express it graphically, but we're going to need two number lines now. We're going to need a number line to express the x value. We're going to need a number line to express the y value. And so we will use a coordinate plane when we graph our solution set. We would use ordered pairs where your x value is going to go on the left and the y value is going to go on the right. What you'll find is that there will be more than one answer that will make this equation true. So let me just go ahead and start plugging in some numbers. Let's say that I would want to see what the solution set would be if x equals 0. I would start with my table and I would substitute 0 for x, then I'm going to have a -6 for y. And that's how I can start graphing. So my first solution set, my first ordered pair here is x equals 0 when y is -6. We're going to call that point A. And I can begin to build my table. If x equals 1, then my value is going to change, and y is going to be equal to -1. And I can call that point B. I can call that point C. There is more than one point that will make this equation with two variables true. I just simply grab these three whole numbers for x and plug them in. But there are multiple, a line is made up of multiple points in ordered pairs that would work as a solution set for this particular equation. We call these linear equations because when you graph them, they form a line. Your solution set in here is expressed as a graph. Your solution set can also be written as a table or with ordered pairs. Let's say we have this linear equation with two variables. The first thing that I need to do is create my table of x and y values. I like to start at 0, but some folks like to start with their negatives. So we're going to try -1. One thing for you to notice is that we don't have the setup where we did in our last example where it was x equals something or y equals something. So what I want to do, just to make it easy as I plug it in, is I want to rearrange this formula and rewrite it so that we have y equals a value. So to do that, I'm going to move variables and numbers to the other side and leave y by itself on one side. So now I'm ready to go ahead and start plugging in these x values. I'm going to start with my -1. Now I'm going to go ahead and move to 0. Now I'm going to move to 1. And I can start plotting my ordered pairs in my graph. Once I plot my ordered pairs, I can draw my line. The line indicates that there are more than just these three solutions as part of the solution set. There are infinite number of solutions so long as they lie on the line.